This is a transistor. Transistor was invented by a team of three scientists at Bell Laboratories, USA in 1947. All of the complex electronic devices and systems developed or in use today are an outgrowth of early developments in semiconductor transistors. There are two basic types of transistors: the bipolar junction transistor BJT, which we will mostly discuss in this video, and the field effect transistor FET, which we will discuss in next videos. The bipolar junction transistor is used in two broad areas of electronics: as a linear amplifier to boost an electrical signal, and as an electronic switch to control circuits. This is transistor. We use 0.7 volts as the transistor input, and the output load about 12 volt is connected to the output, that is collector and emitter. Now turning on input voltage will turn on output, and turning off input voltage will turn off output. So the transistor is working like a switch. Basically, the bipolar junction transistor consists of two back-to-back PN junctions manufactured in a single piece of a semiconductor crystal. These two junctions give rise to three regions called emitter, base, and collector. Bipolar junction transistor is simply a sandwich of one type of semiconductor material between two layers of the other types. There are two main types when we consider the transistor types: NPN transistor and PNP transistor. A layer of N-type material sandwiched between two layers of P-type material, it is described as a PNP transistor. Similarly, an NPN transistor consisting of a layer of P-type material sandwiched between two layers of N-type material. Usually, small low power transistors are enclosed in a resin case to protect its internal parts. But for high power transistor, they also cover resin case or metal case and attached to a heat sink, which helps to remove the unwanted heat. The symbols employed for PNP and NPN transistors are like this. In most cases, considering NPN transistors, when we keep the flat side of the transistor front facing to us, the pin from the left to right are collector, base, and emitter respectively. In most of the PNP transistors, it's getting reversed. So it will be emitter, base, and collector from left to right. We already discussed in previous video how P-type and N-type semiconductor form. So for better understanding, you have to watch this video how diode works. Link is given in description box. Pure silicon has almost no free electrons. So pure silicon is mixed with a small amount of any other substance to get free electrons or holes. This process is called doping. This doping can be of two types: P-type and N-type doping. Let's see, it is a pure silicon. Each silicon atom is surrounded by four other silicon atoms. Each silicon atom wants 8 electrons in its valence shell, but the silicon atoms have 4 electrons in their valence shell. To solve this problem, they share an electron with their neighboring atoms to fulfill the desired 8 electrons in their valence shell and create a bonding to each other. This bond is called covalent bond. If we add a small amount of phosphorus to this pure silicon, then phosphorus replaces some silicon atoms. Phosphorus atoms have 5 electrons in their valence shell, as silicon atoms share their electrons to get 8 electrons in valence shell, but for phosphorus there are some extra electrons. So in this region extra free electrons are present. This type of material is called N-type semiconductor. Similarly, if we add some small amount of aluminum in pure silicon, then holes have been created, because aluminum has 3 valence electrons, as silicon atoms share their electrons to get 8 electrons in valence shell, but for aluminum there are some shortage of electrons. So in this region extra holes are present. This type of material is called P-type semiconductor. Now the question is how transistor works. Let's see these symbols. The arrowhead is always at the emitter, and in each cases, its direction indicates the conventional direction of current flow. For PNP transistor, arrowhead points from emitter to base, meaning that emitter is positive with respect to base and also collector. For NPN transistor, it points from base to emitter, meaning that base and collector as well is positive with respect to the emitter. Emitter. It is more heavily doped than any of the other regions because its main function is to supply majority charge carrier to the base. Base. It forms the middle section of the transistor. It is very thin, about 10 to the power minus 6 meter as compared to either the emitter or collector, and is very lightly doped. Collector. Its main function as indicated by its name, it is collect majority charge carrier coming from the emitter and passing through the base. In the case of conventional current, the current flows from the positive terminal of the battery to the negative terminal. But electrons flow from the negative terminal of the battery to the positive terminal. Here, we will explain the bipolar junction transistor with the help of flow of electrons. For a NPN transistor, if the negative terminal of the battery is connected to emitter and positive terminal is connected to base, it is called forward bias. Here, the battery voltage must be 0.7 volts as it takes a minimum of 0.7 volts to break down the depletion barrier. In this case, barrier breaks down and electrons of emitter flow across to fill electrons within base, and some electrons are attracted by the positive terminal of the battery. Since the base region is very small and lightly doped, so a large amount of free electrons accumulate in the base. Now, if the negative terminal of the another battery is connected to base and positive to collector, it is called reverse bias. In this case, electrons in n-type material is attracted by the battery. Since base has large number of free electrons and collector also has more electrons which attracted by battery. So base collector junctions depletion layer breaks down and electrons flow from base to collector and current continues to flow through the transistor. For these functions of the bipolar junction transistor, BJT are used as electronic switches. With the help of such a switch, a given load can be turned on or off by a small control signal. If we input a signal to the base pin in C amplifier circuit, then we can amplify input signal. We will discuss transistor amplification in another video. Characteristic curve of transistor is like this. Thank you for watching Physics Fast. For more informative and educational videos, please like, share and subscribe Physics Fast.